Hi, welcome back. Today we're not going to talk about our 3D scanners. Actually, today I want to introduce you a software we recently developed called Revo Measure. So from the name, you probably know it's a measuring metrology software. And if you have basics in the geomagic Rev, you probably know what I'm talking about. So here, let me show you the basic function of it. So as a measure software, widely used in GD&T. So this is what you're going to do most of the time. You import a scan and you import a CAD file as reference. So here I prepared two files for you. First is a scan file. This file can be used directly from, exported from the Revo Scan, the Revo Measure scanning software by STL, the OBJ, and POI, all mainstream formats. So let me import the scan file as a typical blue color, and you know it's a scan. And here, import a reference, a CAD file, normally ended in the .stp format. And here we have it. That's the STP CAD file. So the first thing you want to do is you go to comparison and align the scan and the CAD file together by using either automatically alignment or multi-point selection, the manual alignment. In this case, we just use automatic alignment, and software will just align the two files for us. And we have it. So here, from the appearance, the visual effect, you can already see there are some deviation from the different color of the one of the surfaces kind of off compared to the other, right? But in order to clearly see that, here is this, the overall deviation. Here we create an overall deviation. And we have it. As you can see, the color, the red color means how much it's the plus 0.2 millimeter, and the blue color means minus 2 millimeter, the deviation. But this number is rather big for us to do the real overall deviation. So here is what you can do. Click this deviation map settings, and the range value, we change it to a rather, let's say 0.2 millimeter, which pretty much makes sense, right? And also you can choose the maximum value color or the minimum value color based on what you like. And by default, normally we set it as red and blue. Click OK. And now you have a clear view, see what's going on with the overall deviation here. Okay, now first function, let me show you this. Let's close that. Here, the point deviation. You can calculate the point deviation by simply double-click on any point you would like to measure. And here's, I really like this new software we created. This is really user-friendly. I mean, literally, it's the 5th time I opened this software. Like here, I especially like this. On the bottom line, here are some hints like how you can operate, telling you how to operate the 3D model. And for every operation you will need to do here, it always gives you a hint on how you can click on the 3D model. Like here, double click to view the points of deviation. Like for example here, we want a 1, we want a 2, 3. And here, you just simply hold and drag the box so that you can see it better. Can always create multiple points as you want. And now we have it. And here are something you can do is this little eye icon. You can click that to hide or display all these numbers you are doing. Okay, now let's go to the GD&T. hit measure. Here are the features we support: point, straight line, circle, sphere, plane, and cylinder. So let's go one by one. For example, here, the circle. To create a circle, you simply click, and here this is how you can create from. You can choose a smart fit, and if you have a CAD file, you can directly choose this, create from CAD, or you can fit by selected points. So in this case, we just choose create from CAD, and very simple. You just click somewhere near the circle and hit create, and you have it. Like, you can create multiple circles if you want. So now we have 3 circles. So for the circles, a typical thing you can do is calculate the circularity. Let's say is how perfect the circle is. If you want a further description, you can just hold your mouse on this function button and you will see the description, the form, area of circular features and their cross-sectional circles. And to calculate that simple, go to circularity, you can just select a feature. Let's say, for example, circle 2, and input a tolerance. A tolerance value is a value that you would accept. For instance, let's choose 0.2 millimeter as the tolerance and hit measure. And immediately you will have it. The tolerance is, we said, is 0.2 millimeters. The deviation we calculated by the software is 0.139. So the inspection is a pass. So that's how you do it. And you can also batch hide all of these, all of the data, these boxes by clicking the eye icon on the left side. Okay, now let's do something fun. Now let's select 3 planes. First is the top plane, and the 2 planes on the side. Let's say plane 2. And plane 3. Okay, now we have it. So next, let me show you this function, parallelism. Just say how parallel 2 surfaces are. And for this case, we want to calculate plane 2 and plane 3. So simple, we just choose plane 2. However, in the datum, we cannot select. Now plane 3 is not there. And if you want to see a description, you can also put your mouse there. So a datum means a feature, a standard feature, or a principle. Let's say the datum feature is a specific feature used as a measurement standard. To create a datum, or let's say set a plane as datum, is simple. It tells you how to set a datum on that. So now we want to calculate plane 2 and 3. We just right-click plane 3 and give it a name. Let's say X. And now you can see X from the datum select list. And again, a tolerance we like, 0.2 millimeters, and hit measure. And we have it. It's a pass. Okay, now, you can not only hide or display with the eye icon here, you can also do it right in the main page. Look, that's how it works. So next, let me show you angularity. So it describes the area between a feature and a specified datum by an axis at a specified angle. So in this case, we do, let's say, plane 1 and plane 2. And of course, in order to do that, we also need to set plane 2 as datum, let's say datum Y. Hit Y. And you don't have to worry about the set angle because the software will automatically read the angles from the CAD file. So it should be 90 degrees. So we want to see the GD&T, we just do another tolerance we set, 0.2, and hit measure. As you can see, it's a fail, which means the deviation number is larger than the tolerance we set. Or we could try again. Let's say plane 1 and plane 3 as X. Same thing. So as you can see, the angularity measurement 2 is a pass. So That's the angularity. Okay, let me just hide it. And now true position. Let's do a sphere here. Look, there are two typical balls on it. We'll just create a sphere, let's say sphere 1. So now let's calculate true position. True position means the position error of a selected feature based on 3 datums. Pretty clear, right? So let's say the sphere 1 we created, and we use plane 1, 2, 3 as 3 datums to calculate the true position of it. And again, we need to select plane 1 as a datum. Let's choose Z. So just X, Y, and Z. Again, let me set a value of 0.2 millimeter and hit measure. So we cannot select that as a system because those 2 planes are too similar. So let's choose another plane. Let's do a plane 4. Okay, and set plane 4 as a datum, let's say W. Now again, let's go to true position. Sphere 1, so W, Z, and X. And now the true position we have is a fail. Okay. Now, hold on. Now, let me hide all that. And flatness is pretty simple. It's just how flat a plane or a surface is. Let's just say plane 1 and set a tolerance of 0.2 and hit measure. And we have it. It's a pass. Okay, now cylindricity. This is typically for cylinders. So now let's create 3 cylinders. Let's say cylinder 1, 2, and 3. Let's hide the plane 1, hide the flatness 1. Okay, cylinder 1, and a cylinder 2 here, and a cylinder 3. So let's calculate the cylindricity of one of the cylinders. Let's do cylinder 1. Again, set value 0.2 and hit measure. We have a fail. How about cylinder 2? Another fail is cylinder 3, which is a pass. So cylinder 3 is pretty much a perfect cylinder we have here. All right. Let's just hide that. And now we want to calculate the concentricity of the 2 cylinders. For example, cylinder 1, cylinder 2, and 3. And again, we need to select cylinder 3 as a datum. Let's just pick a random number. And if you notice that the letter you set for datum will disappear from the list. So you will never get confused, which is pretty cool. So cylinder 3, actually cylinder 2 and cylinder 3. And value 0.2. And it's a pass. Okay, now I'm going to show you how to calculate the distance of 2 planes. So let's enable all the planes here. Plane 1, 2, 3, and 4. So we want to create another plane. Let's say plane 5. Create. And let me hide 1, 2, 3. Let me drag the plane 4 here. Plane 5 here. Okay. So to calculate the distance, simple. We just hit distance. And we choose plane 4 and a plane 5. And the tolerance, now you see 2 numbers here because now we want to calculate both minus and plus. So let's do minus 0.2 and a plus 0.2. Let's hit measure. And you see a pass here. So the tolerance we said is 0.2. The reference is the distance of plane 4 and 5 from the CAD file, which is exact 200 millimeters. While the real measurement from the 3D scan file is 199.93. Well, let's just do a quick test. Let's just do 0.02. 0.02, 4 and 5, and hit measure. You will see that now it's a fail because the real deviation we have is 0.03. So that's almost every function I've showed you in the Revo Measure. After you finished your calculation, you can hit this, generate report. You can get a file name, like for example, ash1117. You can save path to the report here, and the company. Let's do Revopoint. Department. We'll say video production. Project name, part name. You can just and also you can show to disable or enable any content that you wanted to be included in your report, and just hit export. And here we go, we have it. And the report includes a lot of data that you will need, like overall deviation, the point deviation we calculated, the circle one properties, all the way to all the planes, the sphere, the cylinders. And here are the GD&T part, the circularity we calculated, parallelism we got, and they are all automatic. You can just get this report by simply clicking export. So we'll significantly improve your workflow efficiency, huh? And of course, you can trust this Revo Measure. It's because we did send them to Germany, get it certified in PTB. Metrology Institute, and here are the results. This is what Revo Measure has. It's within or less than 0.1 μm and 0.1 urad. So definitely it's a software you can trust. And now we are about to put the Revo Measure on shelf. The pricing will be $499 per year for 1 year license, which is a really great price. And for 3-year license is going to be $999, and of course the lifetime license will be $1,999. And for the updates, before for 1.x version, now it's 1.0 version for Revo Measure. So for 1.x, you always get free upgrade within your license date. Okay, hope you like this software. Let me know. See you next time.